Okay, so the first thing we want to do to make sure that this is the correct scale is to draw a rectangle that's the necessary proportion. So I'm going to go to my top view, change this to the rendered style so I can see everything. I'm going to draw my rectangle. In this case, it needs to be 10 by 10. So you can see this one's way too big. So let's just go ahead and move that down. I'm going to select everything except for that curve. Let's go back to this view. Find that rectangle. There it is. Let's go ahead and just put that on a different layer. So let's not put on that layer, of course. So now I can select everything on this layer. Oops. And then I'll just scale it down in this case. So that way I can kind of get it to where it needs to be. Most of you, like I said, most of you probably aren't going to have to go through this rigor. But in terms of once you get it matched up, then you can apply that to your own. Okay, so I'm just going to move this one down. Okay, so I have it about the right proportions it needs to. So again, this is probably where you guys will start having this rectangle. So what's going to happen if you bring this in, you'll see that it's just a bunch of different meshes. In order for most of these scripts to work, it needs to be one single mesh. So we need to join all these meshes together. When we do that, because those are all separate meshes with their own separate texture map, it's going to lose that texture because they're no longer in those fragments, but it's one whole mesh. So the best thing to do is to go ahead and select all your meshes and copy them. We type copy and then do in place. It's just going to copy right where it is. And then put that on a separate layer. So I'm going to now do better and actually label these. So we'll title this clay terrain. Relabel this one 123D terrain. So that should be okay now. So now I'm going to make my clay terrain active by clicking next to that light bulb, turn off this one, and should pretty much be the same as is. But now I can select everything and type join. Now you can see it's lost that texture because now it's just one entire mesh. It's no longer those separate pieces. So with that, now I'm going to trim it just because there's all this overlap. I'm sure a lot of you had some of that overlap as well from your model. So this is a good way to just trim that away. So I'm going to take that curve now, do extrude curve, change it from a solid to no, both sides. So that way it's going to go through the entire mesh. Now I can do mesh split. That's my command. Select objects to split. That's this. Hit enter. Select cutting objects. That's your rectangle or your box. Hit enter. It'll take a second. Now you can delete this. Now you can delete all this excess. So now you have just a nice clean edge to your clay model. I'll just keep this on there. Okay, so with each of these scripts that we're going to use, each one is going to treat the mesh a little bit differently. In the last class, we looked at all the different properties that make up the stormwater management calculator. One of them included the slope conditions or slope percentage. Another one included the drainage patterns themselves. And then lastly, there was the land cover type. Depending on how far along we get today, we'll cover at least the slope percentages, the drainage patterns, and possibly the land cover type. The land cover type's pretty easy. But these are all the components necessary for the stormwater calculator. Again, I know we haven't gone through the entire extent of that calculator. That'll be next week. But for this will at least make sure that your model is prepared for the next session of class. So now that you have your model generated, you can choose to reduce this because there's so many points. I'll go ahead and do it once by going to Mesh, Mesh Edit Tools, Reduce Mesh, Reduce to, so you can choose how many polygons you want or by a percentage. I'll just try and do 50% for now, so it drops it down to 64,000. I'll get a little toolbar going there. So now it's a little cleaner, a little smoother. Again, it's going to be a process for you guys to determine how much you need to reduce it in order for some of these scripts to work. Okay, so now that I've done that, I'm going to start Grasshopper. For those of you that haven't used it, this is a plugin for Rhino. It's free online. I'll provide any of the additional plugins for Grasshopper that you may need, but for the most part, it should be pretty simple. And again, I know some of you haven't had exposure to this at all, so I'll try not to rush through it too much. So the first thing we need to do is actually bring our clay model train into the Grasshopper interface by referencing it. So in this first tab of parameters, you can see that there's the different geometry types. So you can bring in points, curves, surfaces. In this case, we want to bring in a mesh. So we can go to our mesh component. We get this orange guy because it needs a reference mesh. So we can right click it, say set one mesh, select our mesh. So now you can see that it's gray, which means it's acknowledging that there's something there. We have this red overlay indicating that's the Grasshopper mesh that's being displayed. So I'm going to go ahead and just turn that layer off for now because I don't really need to see the Rhino terrain. I just want to see my Grasshopper terrain. And so now we want to actually start to analyze this and determine what the slope percentage is of our respective terrain, in this case your guys' own. But it's going to require the same exact script, so it should be easy to translate this directly to your own model. So the thing we need to do is just deconstruct this mesh to find out the vectors or the directions of our slope. So you can go over to our Mesh tab, deconstruct mesh. Now we're seeing this triangulation and points of all those elements of our mesh. We can turn this off by just right-clicking, turn off preview, because that's not really that important. From this deconstructed mesh, you can see it gives us points for that mesh, the faces, and then more importantly, the normals, or these are the directions of our mesh. So these are essentially finding that tangent of our surface and pointing it perpendicular to that. So we need to figure out the actual percent of these slopes throughout this entire mesh. So we can do that. So we go to normal. So we need to compare this direction with a vertical line in order to find out the angle of that vector. So I'll go over to vector, then the vector tab, and look at angle. So I'll drag this in as our first angle to look at. And now we have to compare this angle with a vertical angle so we know what that difference is. So if I double click this and type Z, you should get this component unit Z This is going to be our B. So we're comparing all these different angles to this Z angle. And you can find that also by going to vector unit Z. So for those of you that might be a little unclear as to what we're looking at, a good way to look at how it's working is that if you go to curve, primitive, and line SDL, this is basically going to generate a line based off of a direction or a vector, just like what we're doing here. I always use this as kind of a reference to make sure the angles are correct. So I'll drag this into my start point. Direction, so that's this. So you can kind of see you want to match that same icon that we're seeing. So we have this black hexagon with an arrow in it. This direction component is looking for that same kind of icon, so we can drag that into there. Now if I zoom in, we can kind of see this kind of grassy looking thing, which is basically saying where all those mesh faces are pointing perpendicular. Does that make sense for the most part? So I'll just delete that. That's just more or less a visual reference. And so this is giving us an angle in radians. I don't know about you, but I rarely ever look at angles in radians units. In this case, for this class specifically, we need to know angle and slope percentage. So we have to do a little conversion. So we can go over to our math tab, go to trig, and do tangent. Drag this into our tangent component. And then we take this value and we multiply it by 100. So if I hold shift, I'm going to get the quote mark, hit type 100. Drag that into there. So now all my slope or all my angles have been converted into percent slope. This is something, it's just a little unit conversion. I had to look online to actually do this a while back to figure out how you actually do that, but this is just something to know whenever you're wanting to know what that slope percentage is, that you have to do this little unit conversion operation. So now that we have our slope percentage, we can start to assign each one of those slope percentages a color related to that slope percentage. So first thing we want to do is get to our bounds. So staying in the math tab, I can go bounds and click this in here. And this is basically going to show me what my highest percentage is and what my lowest percentage is. When I hover this, you can see that it goes from 0.09% slope to 1,207% slope. That seems a little high for a slope percentage. It could actually be that, but that's somewhere between 45 degrees and 90 degrees. Once you get to like a 90-degree angle, it's essentially an infinite value. And when we start to have these really high values, it can really throw things off. So we can essentially cap that value at something. In this case, we want to cap it at 100% because we can associate that any slope percentages over 100 is going to be detrimental to the project anyways. So if I go into utilities and choose minimum, drag that into there, and now I want to essentially say that every value that comes into here that's above a certain value, it gets capped at that value. In this case, I'm going to do, again, 100. So quotation marks, 100, hit enter, and I'll drag that into there. And now we can see, oops, so we don't want the bounds. We actually want this multiplier. So I'll drag that into there. And now you can see, so again, the original bounds were 0.09 to 1,207. Now the new bounds are 0.09 to 100. So that's all it did, was kind of reparameterize that value. So anything that went above 100 stops at 100. So now that we've got that kind of reestablished, now we can use that bounds again. So I'll just undo that. Now we want to take these bounds and deconstruct them. So if I say again, math domain, deconstruct domain, and drag that into there. So now I can see that I have my own output for each one of those values. So now the fun part finally. Now that we've essentially got each one of those curves that I was showing earlier, their associated slope percentage, we can again give each one of those surfaces their corresponding color. So we can see where all our low percent slopes are versus our high percents using those different color values or gradients. So I'll go back over to my mesh tab and do construct mesh. This is looking for, again, those vertices, the faces from the mesh that we deconstructed at the beginning. So I'm just gonna drag them into their same parts there. Turn this off now. And the next thing you can see that's coming out of that or asking for is colors. So this is what I was saying, where we can start to associate colors based on those slope percentages. I'll go back to my parameters tab, input, and do gradient. You can see that it's asking for a lower limit, an upper limit, and all those values. In this case, we have our domains that provide our upper and lower limits, and then we have all the values that are being looked at. So I'm going to drag this into the T value. This one goes into list, lower limit list, and then the upper limit list. And now I can drag this into here. You can see that it gives this pink gradient based off this slope. It looks interesting in itself, but we can use a different color associated with that. So if I right click this, go to presets, and it provides a couple other color gradients. This one of green to red is a common color gradient showing slope percentages. Kind of gives this interesting infrared look to it. So you can start to see for your terrain, all those values that are exceeding that 100% slope and where they start to decrease and get flattened. Something to also take note of, for the calculators that we're going to be using, the highest slope percentage that it considers is 30%. It essentially says that everything above 30% is going to give you the same return. So you could actually change this value to be 30. So that way we know how many of those values start to exceed that 30% slope. And those are going to have their own respective values. You can see it entirely changes the model, but it starts to tell us where those issues of a 30% slope are versus the remaining part. So yeah, this is a fairly simple script in order to generate that part of the assignment and the exercise for exercise 1.2, I believe, where we need to start looking at all these values. So I'm going to go ahead and pause this for now. So like I said, we want to also look at the drainage patterns for this clay terrain. The drainage script that we're going to be looking at needs to see a surface, not a mesh. So you could use, there's a couple scripts out there online that look at meshes, but for this we can use a plugin as well, which I'm going to use for this exercise. So again, we need to redo this so that it's being treated as a mesh. There's a couple ways to do that. We've gone over it in other classes, how to convert this to a mesh. I'm gonna just take the simple route of draping over this. And the reason for that is because some of you may have some undercutting, which will cause some issues for the drainage script. But if we drape it, that'll essentially create a vertical surface, which will help to alleviate that. So I'm going to go ahead, create a new layer and call this drainage terrain. I'm going to go over to my surface and choose drape surface over objects, or always type drape if you want to as well. So I'm going to go ahead and just draw a rectangle over here. It doesn't matter if it's matching or not, because again, we can trim it away. So now I have my new draped surface. So let's turn off that terrain. So there's something kind of weird going there, and a couple, but it does help kind of refine that resolution of it. I'm going to go ahead and trim that away again by using that same rectangle, extruding the curve in both directions. Say trim or split, doesn't matter. Select cutting objects, select objects to trim, so that's this excess. I'll hit escape to get rid of that, and there's our new B-rep, or surface in this case. Okay, so now I'm going to do the same thing like I did before. I'm going to reference this into Grasshopper. So I'll go back to my parameters, geometry, and now instead of mesh, I'm going to use surface or a B-rep. It shouldn't really matter. I'm going to stick with the B-rep. Say set one B-rep, select that. Again, I'm going to turn that off. So you can see it is definitely a little bit smoother. If you want, you could always take this same B-rep that seems to be a little bit smoother now and run this through your slope analysis. So what I could do as well is I could go to mesh, mesh to B-rep, or B-rep to mesh. Turn that off real quick by hitting spacebar. So spacebar brings up this kind of quick display of some of the common icons. You can turn things on and off using this. So like I said, I'm turning those off, and I'll just drag that into there. Then I'll turn it back on. You can see it's a little bit smoother. It's a little different resolution, but it does kind of create and remove some of those issues on the edges. But anyways, and it might be good to go this way. That way they're consistent, that you have the same kind of terrain for both objects. But anyways, so let's go back to here. So I have my B-rep, or my surface. Now I want to know that drainage pattern. So what I'm going to do is, and I'll provide a link to this, or you can look it up online. If you go to this tab, says mosquito, and use this flow component, this is from the Mosquito plugin for Grasshopper. So if you go to foodforrhino.com, they have all the different Grasshopper plugins and instructions on how to install this. This one that you're looking for is Mosquito plugin. This will give you a whole assortment of things you can do. We're only interested in this flow script. So I'm going to drag this into there. And now it also needs points, so the starting point of your drainage script. You can do that in Grasshopper or Rhino. It doesn't really matter. I'm going to do it in Rhino in this case. Again, I'll go to my points. So instead of doing a single point, I want to create a point grid. It's asking for a number of points, and the X direction, 10's okay. I'll hit enter. Y is also okay at 10. And now I'm just going to drag it, maybe not the entire curve, but somewhere pretty close. So now I have my grid of points. Now I go to my perspective, and then I'm going to take these points, and with the gumball, make sure that this is selected so you get this icon. I'm going to drag this above my surface. Then I'm also going to type explode. So now it actually points and not a point grid. Again, I can reference these now into Grasshopper by going to the Parameters tab, the very first one, Geometry, Point, grab that component. And with those still selected, I'm going to right click and say set multiple points. So make sure to do the plural, not just one single point, but multiple points. You can deselect this, drag that onto there. Okay. So now the next thing I want to do is start to create the resolution for my curves. That's going to be these two values. You're going to want for a resolution somewhere between 1 and 10. So if I double click my screen, I can do type 1, then type the less than sign and do 10. If you just type a single value between 1 and 10, it'll create this default slider as well. So I'll do that. So now you can see I have a slider that I can change the value. I'm going to drag that into my resolution. I'll drag this to start at maybe 5, see what that does. And the calculation is going to be how long the curve's going to be. So essentially the resolution is the distance between each points, and then the calculation is how many points. You want a fairly larger number for this, so I'm going to do 15 less than 50. That should be okay. I'm going to drag that onto there, and it creates a mess. So our values are a little too much for now. So let's keep this one. And so each one kind of responds differently, so I have to figure out. So instead, you know what, I'm going to actually project these onto the surface to help. That might be where some of these issues are. So I'm going to double click the canvas, type project, and select project point. So this is going to project a point onto a surface or a B-rep. So I'm going to drag this into my points. Direction, it's already going in the negative Z direction, so down. And then it needs a geometry. So that's going to be our surface. So points, that's asking to project, and then what it's projecting onto, that's just these two components. You can go ahead and turn this off. So now you can see they're all draped onto that surface. And we'll see if this helps. Not as much as I would have liked. So let's keep this high, and maybe we just need a shorter calc value. So if I double click my slider, I can change those values. So in this case, I'm going to double click that, hit 1, double click this, hit 10, hit OK. It's not liking that at all. Okay, so if I increase that value, it helps. So let's make this higher. So instead, we'll make our resolution higher. And there we go. So now, so let's turn that layer back on. Let's actually turn this one off. So you can see how these points are starting to drain on our surface. So you can see how there's these ridge lines are treating it just as is, where these ones are flowing into this area, these ones are flowing into here, and these ones are starting to flow off site. If I turn that off, that also helps. So you can tell just by how you change those values, you can Maybe we want to do a little bit higher. So yeah, that is how you do the drainage script. Again, you can give these their own colors as well. I'm going to turn this one off and I'm just going to give them all the same color. So I'm going to do custom preview. And I'm going to double click again, type swatch, drag that into there. And I guess it would make sense to give drainage lines a blue hue to it. So there you go. There's your drainage script. So a very simple one to do, but when you start to combine this with the other values, it starts to make it pretty powerful. Again, mine's pretty simple terrain too, so that's why it's nothing really too surprising on this. What's nice is that I can, again, select that grid of points. Maybe I want to make it a little bit denser or tighter. And then they'll immediately respond, so you can have something a little bit more revealing and interesting. Obviously, you can have more grids. The other way to do the same kind of thing and make it a little more parametric is that you can take your B rep, so your surface that's been referenced, go up to surface, and then divide surface. This is essentially going to do just that, where it's going to project a set of points on that surface, and then you can control the density of that. So I'm going to double click, do 15 again, less than 50. I drag this into both the U and the V value. And let's jack this up to maybe 20. Now I'll go ahead and flatten this. So right click, flatten. I'll drag that into my points now. Let's turn this off. So again, then you can just simply change the slider to make it crazy. So yeah, that is the drainage script. So between the slope script and this flow script, it should give you quite a bit of components necessary for next week and moving forward to start calculating the runoff volume. So make sure that you've got these working and prepared next week.